Good day, folks. Here's another example of the universal gravitational law. Let's cut the chase. The distance between the centers of spherical mass pieces of 1.8 kg and 3.8 kg is 75 millimeter, as shown in the diagram below. Here are the mass pieces. These two mass pieces, they have that distance there, and you have to convert that distance. You divide by 1000 there. So when you divide by 1000, it's going to be 0.075 meters. Right? So what are we going to do here? There's a gravitational force, which is the force of attraction between the two objects and the distances from their centers. Now it says 7.1 state universal law of gravitational force in words. Guys, I'm not going to waste time on that. 7.2. 7.2, it says calculate the magnitude of gravitational force that the two mass pieces exert on each other. So I'm going to write the formula. That's the first thing that is important. And then I'm substituting. So the G is 6.67 times 10 to the power negative 11. And then mass 1, it's going to be 1.8 kg. And then mass 2 is going to be 3.2 kg. And then all over, the distance is what? Is 75 millimeter. And then you divide by 1000 to convert, you square. So if you punch that in the calculator, your answer will be 6.83 times 10 to the power negative 8 newtons. And that's the gravitational force between them. Let's go to the next question. I hope that makes sense. Let's go to the next question. It says 7.3. How will the magnitude of the gravitational force change? Write the answer in terms of F. Right, 7.3.1. If the mass of one object is doubled, so if the mass of one object is doubled, so how would the gravitational force change? So now, as you know that the force is directly proportional to the product of the masses. So if one mass is doubled, so that means the force is going to be what? Doubled. So the force is going to be doubled. So the new force will be doubled there. So you're doubling the force. The force in the product of the masses is directly proportional. So if you're doubling the masses, one of the masses, so that means the force will be doubled. So the new force here is going to be 2F, which is 2 times 6.83 times 10 to the power negative 8. And then, so the answer there, you times by 2. So your answer will be 1.36. Let's say it's 1.37 times 10 to the power negative 7 newtons. So the new force, if you're looking here, it's 2 times bigger. It's 2 times bigger. Now it says what will be the new force if you change the gravitational force if the distance between the masses is halved. So 7.3.2. So if you're halving the distance, that means the force is going to be okay, let's look at that. The force and the distance are inversely proportional. So if we are halving the distance there, so we'll put the half r squared there. So that means it's going to be 1 over 4r squared. So the new force now, if the distance is 4 times bigger, if you look at the distance now, it's 4 times, not bigger, 4 times lesser the distance when you square it. That means if the distance is 4 times lesser, so that means the force, so that's the distance, that means the force, it's going to be 4 times bigger because there's an inverse proportionality there, so it will be that, right? So the force is going to be 4 times. So the force there, it was the force, what was the amount? The amount is this. So it's 6.38, right? 6.83 times 10 to the power negative 8. So it's 6.83 times 10 to the power negative 8 times 4. So it's 2.7. It's 2.73 times 10 to the power negative 7 newtons. So the force there, it's going to be 4 times. Here it's going to be, the new force is going to be 2 times. Hope that makes sense. Cheers, bye.